Yes, I'm sharing my screen. Is my screen visible?
No, not to me. I'll join back.
Yes, ma'am.
Gaurav, you can check from your side. So I've started the recording. Good evening, everyone. I'm Prableen Kukreja, working as a PhD scholar in IIT Tirupati. So in today's class, we're going to cover artificial neural networks. I'll try my best to cover it in depth as well as the broader view also, as suggested by you guys, as well as after like after some part, I'm coming again with some MCQs, like you can see again, like covering the MCQs after every small part, so that you should like you are having the difficulty in MCQs and all that shouldn't be there with your exams. Gaurav, my screen is visible.
Yes, now it's more visible. It was my laptop. It's visible.
So let's start with artificial neural networks. Any idea about artificial neural networks? Any idea? What are neurons?
Brain cells.
Brain cells. So why its name is artificial neural network? Now, can you relate? As someone of you said that it's like brain cells, neurons are that. Now, can you relate? On?
So so between the input and the output, there are like specific nodes that deal with specific parts of the same, let's say, input, and then all of them switch on and switch off and give an output. I think that is
Hmm.
what.
Hmm. So, in simple language, can I say that we are trying to mimic the brain, like the way the brain is, we are trying that our neural network should behave like that only? Can I say? What is artificial neural network? There is a neural network, there are neurons in our brain, and artificial neural network, it is mathematical model which is inspired by brain only. As a brain have different types of neurons that are connected with each other. Why and what they are doing, they are like whatever I'm telling you, you are basically processing the information. Whatever I'm telling you, that's what you are what your brain is doing. Now the same way, this artificial neural network, they are trying to do that. They are trying to mimic the brain. They are inspired by the brain itself. So here we'll see like input is given, like we usually see in computer as well, like a raw data is given, and the same way ANN, like how it works, like in brain, I'm sorry, a raw data is given, and then some complex things are happening, and then you come up with the decision. The same way in ANN also it happens. Input layer is like raw data, which are features and all, then some computation, some transformations, everything will happen, and then there will be a prediction. So basically, and talking about like ANN, some scientists, some part of society, they take it as a like biological relevance, but some deal it with the like not, they are not worried about the biological relevance. Okay, let's come to the important part. So what we are doing, they are pulling up the inputs from variety of neurons, doing some computation, and seeing that which neuron will actually fire, and another input will be activated. So some input is there, and basically some computations are happening here by the input, and someone gets fired, like this gets activated, this neuron gets activated. So what neural network can actually do, or what can you do? Okay, let's try to understand with the help of Maxlow-Spitz model. So what does Maxlow-Spitz model says? Like it says that these are the inputs, basically x1, x2, xp, and these are y1 to yk. These are excitatory inputs, and this is inhibitory inputs. Excitatory inputs, we have some neurons, they're trying to activate the neurons. Inhibitory inputs, they're blocking the neurons completely. Any doubt till now? So two types of inputs I'm discussing. One is excitatory inputs and other is inhibitory inputs. Inputs are basically 0 or 1. So one type of inputs, they're activating the neurons, and one type of inputs, they're blocking them. So what does it mean when I relate to the brain? Okay, there are inputs which are saying okay to do one task, and the other inputs they're blocking. No, this decision is not correct basically. So some inputs trying to activate the neurons, that are called, now again an MCQ question can arise. What are the inputs which try to activate the neurons? They are called excitatory inputs, and the neurons which completely block the neurons, they are called inhibitory inputs. How it works? Now, what we do, step one, check inhibitory inputs. If in any inhibitory inputs, like suppose if any of the inhibitory inputs, if any of the value is basically 1. So if any of the value is 1, which means it will be blocked. So no matter what are this excitatory inputs, but whenever there is a blockage, we'll not the output will be 0 basically. Now, if no inhibition is there, now what I'm saying, if this blockage is not there, then what will happen? Let's try to understand. Now, the output will be 1 if s is greater than equal to theta, and 0 if s is less than theta. What do I mean it? Like what I'm doing is, there is a threshold value I'm taking here. Okay, I have written already. So if that threshold, I'm comparing it with the threshold and I'm computing the output. Let's try to do what I'm saying is, with an example. Suppose x1 is equal to 1, x2 is equal to 1. So, and y1 is basically, suppose this inhibitory inputs. We have already done this y1 to yk is inhibitory inputs, and this x1 to xk it's exhibitory inputs. So if inhibitory input is 1 in the second case, obviously the output is 0. Okay. Now, if exhibitory input is like this is basically 0, then obviously if we'll take the sum, what is the sum? Sum is equal to 2. Then we'll compare it with the threshold. If it is greater than threshold, then the output will be 1. This is how this simple MATLAB bits work actually. You'll compute the weighted sum and compare it with the threshold. And if inhibitory input, any of them is 1, then you'll not, basically, the output will be always 0. Any doubt? Yes, Gaurav, Megha, Sneh, Yashwan.
What is the in so if I missed it, ma'am. Would the output be one or two if let's say the inhibitory input is okay,
Okay,
output will be one.
one. Basically, we are saying binary outputs only. So
Then
we
how is the sum related?
so it's not like what I'm trying to do is, I am basically taking the sum of the inputs. What will happen? These are the sum. These are the inputs. I'll take the sum of the inputs. Then I'll compare it with the threshold. There'll be threshold, like whenever the sum will be greater than threshold, then I'll say that the output is equal to 1. And if the sum is less than the threshold, then I'll say that the sum is equal to 0. Though there'll be weights also, there can be weighted sum as well, like W1 x1 plus W2 x2, so on till WP xp. It is greater than theta, then the output will be 1. Otherwise, the output will be 0. Is it clear? So this was a very first model. Uh, like when we came to ANN, this was the very first model. Like how to come up with this ANN and all. Like before that, that was McCulloch-Pitts neuron model. So how does it work? We were taking the input sum, whatever the inputs were given, the excitatory inputs. We added them, and then we were comparing it with the threshold. Like and then if the threshold value is like the sum was greater than the threshold, then we were saying the output is 1. Otherwise, the output is 0. Very simple, naive, I'll say model. Very first model. And if any of the inhibitory input is 1, then the output will be always 0, despite of whatever the excitatory inputs are. Fine. Fine, Gaurav.
Yes, ma'am. Yes, ma'am.
What about others? This McCulloch Pitts, it is a very simple McCulloch McLuhan-Pitts neuron model. Is it fine for everyone? So the again, though the MCQs, I'll come up with this after this topic. Though the MCQs can be very simple, whatever they can give you some this type of example saying that, like, suppose one of the inhibitory input is one. Then if any of the inhibitory input is one, then obviously the output will be zero. Some type of this example can be given to you in the exam. Okay. Should we proceed? Can you give me thumbs up? Because I'm not getting any feedback. If you have understood this. Is this fine? Like today I have already made up the, writing up is fine. Okay. Let's first complete the lecture, then you can take the decision. Okay. Now coming up to perceptron again. Do you remember perceptron learning? I have actually taken one whole class for the perceptron learning. What was perceptron learning? Last to last class, whole class was up to the perceptron learning, whereas the professor, I think only one lecture was there. I've taken whole class for that perceptron learning. I hope so you remember. What does perceptron learning do? Can someone tell me? Come on.
Ma'am, it takes input, but it takes weighted input. So it takes input and then assigns a weight to it, and based on that, uh, it will have an activation function. If it is above the activation function, it will say yes. If below, then it will say no. But the inputs are what is decided. The weights are what is decided.
Yes, exactly. But okay. One again MCQ question. Perceptron learning works on all data or only classified data or only misclassified data points?
I think all data, ma'am. It takes all data and then decides.
No. It takes only misclassified data. Remember last to last class, I think you attended only, Gaurav. So, in perceptron learning, we are basically focused on the misclassified. Remember? Okay. Maybe I'll give you just a glimpse of it. This was the perceptron learning. So what we were trying to do in the perceptron learning, obviously it is a linear classifier. We are basically trying to build up a line to separate both of the classes. That is fine. Then we came up with perceptron learning. Any point that I have misclassified is as close to the decision boundary. Remember now? So what I'm trying to say, that if it is properly classified, it's fine. If it's classified properly, I don't care because I'll ignore them. But if it is misclassified, I have to take care and I have to make the set of all misclassified points empty. That is the goal of perceptron learning, to make the misclassified points empty. Misclassified points means the points which are suppose in the class 1, but they are actually predicted as in the class 2. So that points, basically that thing, I should make it as empty. And then we went to GD and SGD and all those things. And one more thing. Yes.
That was literally, ma'am, SVMs, right? Like the huge optimal separating hyperplane if it's closed. I didn't realize perceptron is like that.
Okay, wait a second. Now giving a broader view of all of them, so that in perceptron learning, so that you shouldn't get confused and have all this listen that I'm not giving broader view, I'm going in depth. So let's go to once more about perceptron learning, SVM, and then I'll come to other Adaline and all. This is the new one which we do. Perceptron learning. Perceptron learning was, I have set of all misclassified points which I want to make it as empty. I don't want any misclassified points. Now you said me correctly that I want optimal hyperplane. A very important MCQ which I discussed with you. Perceptron learning, there can be many solutions. There can be many hyperplanes to separate the class. But for SVM, they can. What I am trying to do is an optimal hyperplane. You find the difference? SVM, I want an optimal, best hyperplane. Best hyperplane, how was I finding? I was saying that the margin here, I draw the margin. I was saying that the margin distance should be maximized as much as possible. Remember, in perceptron learning, I'm only focusing on misclassified points. Then in SVM, I also come up that only I'm concerned with the support vectors. These support vectors. What are support vectors? Which are on the margin. Now, as I told you, an important MCQ, there can be many solutions for perceptron learning, but there is only one best solution for SPM, as you have only told me that, ma'am, we were trying to find an optimal hyperplane. In perceptron learning, we are not trying to find an optimal hyperplane. We are finding a hyperplane, but that may or may not be optimal. There can be many hyperplanes which are trying. And one more thing, if it is linearly separable, the class that data is linearly separable, then perceptron learning will converge. We saw that also. But if it is non-linearly separable, then there can be oscillations. That is what we saw in perceptron learning. Any doubt now? Have you recalled?
Ma'am, is perceptron learning, as you mentioned, it is applicable for misclassified data. So, is it perceptron learning is applicable only classification kind of a data set? I mean, there is a regression a type of problem, and there can be classification. So, perceptron only applicable to classification?
Can someone answer him? What he's saying? Yes.
Yes, it is regarding classification because the task is to separate the data points into two distinct zones.
So what we have done, that perceptron is actually, as you asked me, perceptron is only applicable for classification. Yes, perceptron is applicable for classification. Now I'll come to Adaline, which is applicable for regression style. Okay. Perceptron is only for the classification. Very good.
Okay. Yes. Thanks.
Now I'll come up with another model, Adaline, which will be to the regression style, for the regression. So as we have recalled that in perceptron, we were having the we were trying to make the misclassified points as null. So we were trying to make that M set empty actually. And how we were doing, how we were trying to find the parameters, like our goal is to find the weights. In linear regression, we did differentiation equated to 0, find out the weights. Logistic regression, we did something like log likelihood and all. And then what we did in perceptron learning, anyone? To find out the weights? Was it not that simple, taking the differentiation and equating to 0, or there was a difference? How we were finding the weights in perceptron learning? I mean, beta and beta naught and all. Come on.
Ma'am, we were differentiating it and then we equated it to 0 like that.
Are you sure? We were not doing anything? You are correct. Like in normal problem, we usually do this. Differentiate equate to 0. But what about in perceptron learning? Have we done GD, SGD, gradient descent and all? Am I correct by saying that? Why we did gradient descent? Because the set of M changes. What is GD? What is the difference between GD and SGD? Again, I'll repeat. Yes, come on. Come on.
In gradient descent, you take all points into consideration and then make a move. And stochastic gradient, you'd only check one point and then you'd only you'll go down the curve after checking if it has reached or not. You won't check all points together.
Exactly. So in gradient descent, like I have given you a very layman example also. Like I want to go to the bottom of hill, I am blindfolded. What I'll do in gradient descent, I'll ask all the villages and then I'll take the decision. And grade in SGD, I'll ask one villager, then I'll move some step, then I'll ask another villager, then I'll move another step. So in SGD, we are taking step like one decision we are like one observation we are taking, then taking a decision. Then another misclassified point observation we were taking, then another we were trying. Then again we were trying to update it. So that was basically SGD, taking one misclassified point, then trying to update it, again and again doing that. In GD, what does it happen? Take all at a time and then update it. That is basically GD. Now in SGD, obviously the noise can be there, but in GD, on the other hand, the time can be more time consuming it can be. So both have their pros and both have their cons as well. So let's see one error. What is the error function? Normally, what is the error function? I'm not relating with the GD, SGD or something. I'm just asking what is the error function. Let's try to see. Sorry, I'm not relating with perceptron learning or something. What is this target? What is this? What we have computed? The sum. This is basically MSC. This half only we have taken just as a constant, nothing, no relevance of it, just so that when we'll take the differentiation, so this 2 and 2 will be cut out, nothing else. So this basically is MSC. Any doubt in this? Come on.
No, ma'am.
So,
just a minute, ma'am. This we are talking about classification problem, right?
I'll come.
Yeah.
Till now, the perceptron learning SVM, we have talked about classification problem. Now I'll come to Adaline. That is a regression one. That
Okay.
to deal with the regression. I'll come to that. So, okay. Classification and regression, you are clear with those now. What is classification? What is the regression? The difference is clear now. Yes, who asked me the question?
Yeah, yes, madam. The difference is clear, madam.
Yes. So, what I'm trying to do now, I'm finding this was error. Now I'm finding the delta, that is the differentiation. So how I'll do that is 2 and 2 will be cut off, and this minus xi. Why minus xi? Because f of xi is basically beta transpose xi. So when I'll basically differentiate it, so I'll get this minus xi. Any doubt? What I have done, can anyone explain again?
That's the chain rule, right? The minus xi.
Yes. It's exactly the chain rule, nothing else. Just 2 into y minus f of xi. F of xi is beta transpose, as we have done it many times, like beta naught plus beta transpose xi. So when I differentiated with respect to beta, so it was basically xi, and the minus was there, so minus xi. So then what is this? This is basically the update. How we have done it? Simple gradient, like we do the gradient descent the same way we have done it. This is basically what we call it as Adaline. So what I have written, can someone tell me now, as we have discussed in perceptron learning also in detail, can you tell me what are these? What is this? What is this? What is this? Like, can you tell me what are the values I'll take? What is this actually?
So we calculate the gradient and then we multiply with the learning rate to get the new beta.
So exactly, you are correct here. So what is the learning rate? Okay, this was the error. This is the error function. We took it. Now we differentiated it. And
Learning rate is a hyperparameter which is it.
learning rate or the step function, basically it is a hyperparameter. So what we usually do is beta. This is the new parameter, the updated parameter, the old weight plus the learning rate, as you have told, or the step function into the gradient of this error function. That is how we usually update our beta values or the weight values. Now, what should be the step function? We have already discussed. Should it be very high? Should it be very low? What will be the, again, I'll ask some questions now. What is the relevance if I'll take it very, like what will happen if I'll take it very high, and what will happen if I take it very low?
Very high, it will oscillate around the lowest minima, and very low, it will take a long time to reach the lowest minima.
Accurately, accurately answered. So, as he has said that very low, obviously it will take a long time because I'll take what is this learning rate or what is it, how I am taking the steps. If I'll take it very low, obviously it will take a very long time. If I'll take it very large here, I want to reach here, obviously I'll oscillate here. So I have to take something, a trade-off between them, and I have to find out what should be the optimal this learning rate, as he told that it is basically a hyperparameter. So that is there. Now, can you tell me this? This is basically called Adaline. We have already done a type of this. Like it looks similar to perceptron learning. Perceptron learning also we took some error function, something like that. We took GD. Now, what is the difference between adaptive learning neuron? This is called adaptive learning neuron, and and between the perceptron learning. Can someone tell me? Let's try at least. Try to recall the class of perceptron learning. Come on. Any idea? One difference I have told you now only. I think someone asked me. Shrimani Pandit, I think, asked me about something. I told you the difference, one of the difference. Come on, come on. I told you that this is Adaline. We already have discussed what is perceptron learning. Now, what is the difference? Try at least to answer.
Ma'am, actually, I am. I have a question that I mean we discussed that this perceptron for misclassified data. So now this Adaline, is it analogous to perceptron in case of regression? I mean, in case of regression also, if some data, I know it, we cannot say misclassified, but suppose some data which we could not be able to consider. Um, so in order to accommodate or in order to make that data null, is that the method that we are looking into?
Okay, exactly. This is one of the difference which you have told. As you have told that main difference between perceptron and Adaline, as you told me, I have also told you that we update only the misclassified points in perceptron learning. But here in Adaline, it is not analogous. It is in Adaline, we are updating all the points using the gradient of MSC. Like we are updating here all the points. But in perceptron, we were only updating only the misclassified points. This is one of the main difference between perceptron learning as well as Adaline. The second one, which I have already told you, that obviously it is continuous, so it's type of regression there, which and that was a type of classification. And okay.
Yeah.
So let's try to one more time come up with the perceptron learning. Try to see what we have done in perceptron learning. So we have basically, when we were doing the perceptron learning, what we did, we had a rule like, okay, we'll see the sign function of this beta transpose xi, fxi, and then we were taking here like beta plus in our gradient function y minus fxi into xi. Like this is basically our this is our gradient of that because here I am taking this fxi here is not beta transpose xi, it is the sign of beta transpose xi, whether it's 1, whether it's 0, or however. Like obviously if it's 0, then there will be no update or so. And if y is equal to fxi, which means correct, which means no update, as I have already told you. If y is not equal to fxi, which means it is misclassified, and we'll basically adjust the weights. This is how this perceptron rule, basically perceptron learning, do work. Now in Adaline, now here we were taking the threshold, like there was a threshold that was deciding the sign and all. Here the predictions are before threshold only. The error here, fxi, basically it's beta transpose xi only. It's not the sign of beta transpose xi. It's itself beta transpose xi. So it's not, it was every sample, not only the misclassified one. Clear? Any doubt? Any doubt?
I don't know if Adaline is a part of our syllabus, so I'm missing it.
Adaline is a part. Actually, professor has told you in the very first lecture of ANM.
And would you please explain it once more?
Okay, it's fine. Okay. I'm doing nothing. I'll tell you about first perceptron. We'll try to recall it, and then
Basically gradient descent only, or something else you are telling?
yeah, let's try to again. Gradient descent is nothing but update rule. How we update our grade pattern. Okay. Now we have used this gradient descent in perceptron learning, as well as now we are using this gradient descent or SGD in our SGD or gradient descent in our Adaline. Now I'm telling you, let's take an error function. Error function, which is an MSC only. So I took the error function. That is what I took it in update step. This update step. This is the error. FXI is basically beta transpose xi. What we did in perceptron learning, first try to understand it. I took a threshold. If it is greater than that threshold, then I'll take the sign as +1. If it is less than that threshold, I'll take the sign as -1. That is what we did. That wait a second, maybe. What we did is, if yi x transpose beta plus beta naught, something like that we did did that if x transpose beta plus beta naught is greater than 0, then label it as +1, something like that. We took the threshold and all. And then we say that, okay, what will be the sign of this beta transpose xi in perceptron learning? And that we took in, that basically that was our fxi. What was the fxi? What was the output function? Basically the sign, whether it's +1, whether it's -1. And then we incorporated or substituted in our update rule of the gradient SGD. So this is the SGD, new beta, old parameter, plus step function, and y minus, this is the differentiation of our, basically the same thing, only in this f of xi, it was basically the sign function, sign of that. In Adaline, this f of xi is basically beta transpose xi only. It's not basically the sign. Now here, what we were saying in perceptron learning, we were saying that if yi is equal to fxi, there'll be no update because it is correct. Why there'll be no update? Because this will be equal to this only, so it will be correct only, so they will not take any update. Here, y is not equal to f of xi, then basically we'll adjust the parameters. But here in Adaline, for every sample we'll do, not only for the misclassified one, we'll do for every sample. That is basically in Adaline. Here in perceptron learning, it was for misclassified point. Let's try to find the one more thing, like difference. So here, obviously, it's basically for the, if telling about f of xi, it's binary output sign, either +1, either +1 or -1, or either 0 or 1. Here we are dealing with the only and one more thing, what it means, it means that here only for the misclassified points it will trigger up. Here basically it's like beta transpose xi, this f of xi, and for every point it will be triggered.
Ma'am, let's say it is correct. Like, for example, y is equal to f of xi is correct. What is it calculating?
There it was the sign thing, na? Why, like, okay, you are
Oh,
saying
for classification, yes, it's sign.
it's sign.
Plus or minus.
Now let's see here. Exactly. Now this is the main question which you should ask. Now it's like +0.2 and the sign is basically +1. So it's basically correct only, like correctly classified in the sense. So I'll say that it will not do anything, perceptron learning. But what I am saying that Adaline will do. That is what I am saying. Na? What will Adaline do? What is it saying 1 minus 0.2? What is the difference between, like, okay, Okay. For this, it's not like classification. It's like a regression problem. How far it is like, okay, actual output is 1 and the predicted one is 0.2. Now, how far it 0.2 is basically from 1. Are you getting? This is a regression thing. This is a continuous thing. This is a continuous linear output. That was a discrete one. That was either 1 or 0. That was a classification problem. Now, here the answer, the output should be +1, but I'm getting +0.2. It's not classification.
Got it, ma'am.
So what I'm trying to do, how far it is from the +1. So for all points I'm doing here. Obviously, I have to do for all points now. Okay. Any doubt? Am I making sense to everyone? Please give thumbs up if you have understood.
What is the objective of this Adaline?
Okay. Obviously, if I talk about perceptron learning, can you tell me what was the objective of that? I'll come to this.
Linearly classifying the points into two separate regions. If it is the points are linearly separated.
Okay. Now, can you try to, okay, you are exactly correct that I have to make the linear separable line for, if the points are linearly separable, then I have to make a line basically. Now, what can be the, can you look at this example and can you tell me what can be the objective of Adaline 1 minus 0.2? Can I say to reduce this MSC? I have some true label, I have some like output. I want to minimize the distance between the predicted value as well as the true value. Can I say that?
Yes, minimize the error.
Minimize the error. That is basically the objective of Adaline, to minimize the MSC between the predicted output as well as the target output, as well as the true output.
Yeah, I mean, that is the objective in a linear regression, simple linear regression, is to minimize the sum of square errors. So how is it different from that?
Can someone answer him? Okay. What he's saying is that the in linear regression also basically it was that only whatever we are basically trying to do the regression there also we were trying to minimize the MSC. Here also we are trying to do that. Can I say? I'll write one line. Adaline is actually linear regression trained with gradient descent. We are doing that only. You are absolutely correct. Can someone answer it?
What is the difference between Adaline and
Linear. He was saying what is the difference between Adaline and linear regression? Why not to do linear regression only? So linear regression, I'll say in linear regression also, as he has told it very accurately, that in linear regression also we were trying to minimize the MSC. What is Adaline? Can I say that it's linear regression trained with gradient descent? It's basically a base build up for the new ANN basically. That's why I'm coming with the Adaline. Just to make a base for the online learning and backpropagation, we have to understand this Adaline. It was, I'll say, to understand this neural model and all. Any doubt?
ma'am? What is the update term for beta? For Adeline, I missed that. Is it exactly the same as at least the
Okay. It's like GD only, na? Gradient descent only. We are basically doing the gradient descent only in linear regression. It's gradient descent only. But like we were doing in perceptron learning, but here it was like sign was used because it was a type of classification. And here we are using directly the FFX, the value of f of xi, that is beta transpose xi.
okay. Okay. Yes, ma'am. Tell me.
Yes, and okay, difference between linear regression and Adaline. Can I say linear regression is not, I'll say iterative also. Here we are basically, it is iterative gradient descent updates we are doing. It is a statistic method. Here we are basically building a, from start to last, we are making an iterative model. Can I say? Okay, one more point. In perceptron learning, can I say I was basically like working on one data point at a time? How I was working with one data point at a time? I was saying I was doing SGD. I was saying take one misclassified point, then try to update the beta, and then take the next updated point. That was STD basically. That is basically a STD. Am I correct? Any
Yes.
doubts till now, Adaline? And is it clear or is it going above the head? Is it clear? Okay. What does the problem come in perceptron, which we tried to solve in SVM also non-linearly separable, like perceptron is not linearly separable? Let's try to understand it. What I'm trying to say, like this zeros have one denotes one class, whereas plus denotes the other class. The first data point is here. The third one is here. They both belongs to one class, and this 2 and 4 belongs to one class. Can I have a line which is basically to make it linearly separable? Yes, come on. Can I have a line between them, something like this, to make it linearly separable?
No, ma'am. You can't make a line between them. No.
Yes, exactly. So I can't make a line between them to make it linearly separable. So that was the only problem with the perceptron learning. Till now, is it clear the perceptron learning? Have you recalled it? Is it clear all the things we have already revised with the perceptron learning? And I hope so all the MCQs you can solve. And the problem it's non-linearly, if it's not linearly separable, we can't do with perceptron. That was the issue. We also have done that it will keep oscillating. That's what we find the issue here. Now what we can do is we can do some transformation of the inputs. Let's try to do that. What I have done I have done like x1 dash is equal to x1 into minus x2. So let's see this. X1 and not x2. This is what it means. Now, what is not x2? Let's take this minus 1 minus. Can you do it? What will be x1 dash? Can you tell me? Apply this. What is x1 here? Come on, what is x1 here? This is x1. What is x1? You guys are not getting, or like, what is the issue? Why not speaking? Yes, come on. X1 is minus 1. X2 is plus 1, but here it is minus 1. Why are you not speaking?
Ma'am, if it is and, then it'll be plus 1, right?
Wait a second. Minus 1. It's plus 1. Yes. Wait a second. Everything is fine. X1 minus x2. X1 minus x2. Okay. This is plus 1. And this is minus 1. Am I correct? This is -1. Na? This is 1. Na? -1, -1. 1 minute. Let me have a new page and show you. I have -1, -1. Okay. Which means that x1 is -1 and x2 is -1. I took naught of x2, which is +1, and x1, which is -1. -1 and +1, it is equal to -1.
Yes, ma'am.
Now, this is basically x1 dash. Let's do the transformation of x2 dash also. x2 dash is equal to x2 and not x1. x2 is
+1.
-1. No?
Sorry,
X
-1. Sorry.
-1. No? And x1 is +1 because not of x1. Again, it's -1. Am I correct?
Yes, ma'am.
So can I say this will again lie here only -1, -1. This one will lie here -1, -1 after the transformation. This is some kind of transformation we are doing so that we can make it linearly separable. Okay. Now, another one that is this. Let's take this -1 +1. Now, can you tell me what will be x1 and x1 dash and x2 dash? Come on.
They
Ma'am, x1
both
dash
be
equal to 1.
Yes, yes.
x1 dash equal to 1.
They are 1. Is it so? I'm not getting. Who was speaking?
Yes, ma'am, they are 1.
They are 1. What about others? Come on. A simple maths. Yes, come on. Okay, let's try to see once again. x1 dash and not x2 not x2. Okay. x1 is basically x1 dash is equal to x1, that is -1, and not x2, which is -1, which is equal to +1. Exactly, you are correct. x2 dash is equal to x2 is basically +1 and -x1. -x1 is -x1, which is -1. Am I doing it correct? Okay, wait a second. I'll come to you. Don't worry. x2 dash is -1. Oh, +1 and -x1. -x1 is +1. Why it's -1, not +1? Anyone?
That's
It's
like
also written
multiplication.
+1 plus. It's not okay. We usually think and is +1. And is multiplication. We usually think na, because we have done like 0, 1. We have done from a starting that 0, 1 is equal to 0, 0, 1, 0 is equal to 0, 1, 1 is equal to 1 in and then 0, 0 is equal to 0. That's what we have done.
Yes, ma'am.
But if I do it as -1, we were saying na 0, 0 is equal to 0. Usually, why we were saying that and is multiplication? Because we were dealing with 0 and 1. Here we are dealing with -1 and +1. So -1 is actually -1. Because what we were saying 0, 0 is 0. Why not -1, -1, -1? Just we are replacing 0 with -1. Na? Why we were saying multiplication? Because we were dealing with zeros and ones. Gaurav, are you getting my point?
Yes, ma'am. Getting.
Actually, I was also confused while looking the lecture, like why it's not. Then I thought, okay, yes. So this is basically simple transformation I have done. I waited for this point because, and then we have done the transformation. Now I have tried to separate. Now they are getting separated. Just I did some transformation and tried to separate it. Any doubt? Any doubt till now? Give me thumbs up if you're getting it. Okay. Is this XOR? Is this XOR? What is XOR first? Come on, come on. If I'm saying
And
it's
not. And not.
and not, huh? So and not. What we have done, as you said me, and not only we have done, na? If you'll see, this is and not only. Just
Yes.
they did some transformation that was like and not only. So it's XOR. Let's try to see the table of XOR. What is the table of XOR? It's like if we have same, like we usually, for the simplicity, we say that if we have same zeros and ones, we usually take it as 0. If we have different, we usually take it as 1. Or in other words, we say that odd number of ones, then we take it as 1. That's what we usually say. Now, points with output 0, that are basically 0, 0 as well as 1, 1. And points with output 1 is 0, 1 and 1, 0. And what was the objective? We wanted a straight line between 0, 1, 1, 0. I mean, 0, 1 and 1, 0. We wanted a straight line between 0, 1, 1, 0 and 0, 0, 1, 1. Am I correct by saying this? That is what was our main objective. Okay, let's try to see here. Is 0, 1, 0, 1. So I have just replaced this plus with 1 only. So I wanted a straight line between them, 0, 1, 1, 0 and 0, 0 and 1, 1. That's what our main objective. How we fixed it? We did some feature transformation, constructed new features, that is x1 and x2 bar. That is what you said, that it's like and not only. Just did some feature transformation and tried to make a straight line. So this is one of the way to make it linearly separable. Any doubt in the lecture we have covered? Then I'll come up with some MCQs. Then I'll
Just one question, ma'am. If you can go back to that ones table.
yes. This
The
one.
ones table, not 1 0, ones and minus ones table.
Mm-hmm.
This is still and, right?
This is still and.
This is still and, is it?
Yes, this is still
Okay.
and. Actually,
Okay.
we usually think na, that and is like multiplication, but why we have thought in our mind and is like multiplication? Because we are dealing with zeros and ones. Na? Usually like 0 into 1 is 0, 0, 0 is equal to 0. But when it comes to minus 1, we are just replacing it by 0 only, like replacing the 0 by minus 1 only. So it should be the same, na?
Yes, ma'am.
Lows, if I talk in the language like low and high, low is equal to low. So that should be there. Any doubt? Please ask me. Then only I'll come to the MCQs. Any doubt in Adaline, in perceptron learning? Any doubt? What we have done, that Adaline and perceptron learning, they are almost like each other, but the way they are basically, they both are using like GDSD type, but the way they are using, like just they are using they're using the sign function in the perceptron learning, and they are basically only working with the misclassified points, whereas in Adaline we are dealing with all points, because that's like how far it is. It's a regression, so how far it is from the output. And there also we are doing GD. It's like linear regression with GD, I can say, in other words, in simple live words, I can say. Then we dealt with XOR table. Like XOR is basically not linearly separable. That's what I show. Then how to make it linearly separable? We did some feature transformation. I did some feature transformation and we got and or not. When I'll do that, then I'll construct the new features and make it as linearly separable. So let's now come up with the MCQs part. Wait a second. In MacLook-Pitts neuron, please write in the chat. I want everyone should write how it's separated. Can you draw a line, ma'am? Okay. Which, what you are, okay, how it is separated. Okay. Let's come to your answer question. Now, what I said is XOR, it was XOR. Now, I did this one. Okay. Can you see now, Yashwant? Actually, after doing this transformation, my points were this. Like zeros, 1 and 3 were here, and 2 and 4 were here, and it was this. Is it fine, Yashwant? Should we proceed? How it is a line? Can you draw a line? Okay. Can we proceed, Yashwant? Anusha, you have asked a question earlier. Perceptron is that. I'll come to you. Okay. Okay. Let's come to the MCQs. In MacLook-Pitts neuron, which of the following is true? Learning is possible via weight updates. Only excitatory inputs are allowed. Inhibitory dominate. Excitatory output is continuous. Please write in the chat with like the way Gaurav has written 1A, 1B, 1C, 1D. Writing the number as well as the MCQ number. Come on, I want all of you 16 people should answer this question. If you don't know, give me a random guess. Tell me at least. Only one has answered till now. Yes, I'm waiting. Now I'm working the way you want. I wrote the MCQ like 100 pages PDF. I have wrote it for you guys. Now, if I'm making efforts, I also want a response from you guys also. I have made the 100 pages PDF just so that the time shouldn't be wasted. I've made the MCQs because you guys told me. I'm working. I'm giving more of intuition, trying to give my best. But on the other hand, I also want that the response should be from the other side as well. It shouldn't be one way. Yes, come on. Now everyone is saying 1C. Okay. Can someone tell me why 1C? You have answered it 1C. In MacLook-Pitts neuron, which of the following is true? What is inhibitory inputs? What is excitatory inputs? Yes, come on.
So inhibitory inputs are those Y which decide whether the input is allowed or not. Excitatory inputs are the one that activate the neuron. So you had shown us how that if Y is equal to 1, doesn't matter what comes from the excitatory inputs, it would just stop. And there's no weight. So learning possible via weights is not there in maths.
So inhibitory inputs, like they are used for blocking, and excitatory, they are basically used for activation. And if one of the inhibitory input is also 1, if any of them is 1, so basically no matter what is excitatory input, the output will be equal to 2. So that's why, yes.
Just one question, ma'am. I understand the inhibitory and excitatory, but let's say in one of those typical Macaulay-Pitts diagram, there are two excitatory there are two inhibitor inputs. Why do you need two inhibitor inputs?
Okay. So you are saying why not only one inhibitory input? Because it's basically if any of them is 1, it will basically block it only. Why to take many of the inhibitory inputs?
Yes,
Is it
it would have been easier to understand also. Like right now, it was easy to understand, and then it occurred to me, why are there so many inhibitory inputs when one is only required?
Okay. Anyone can answer?
So I think there can be multiple inputs to a model uh, as a inhibitory inputs, and if one of the inputs wanted to control the output, uh, then then in that case this arrangement has been made. I mean, uh, yeah, there can be many inputs inhibitory. They can be 0, but any of that, if it becomes 1, then the arrangement may be such that the output should be 0. So
Yes.
now maybe if you can give some example that can make understanding clear.
Exactly. It's exactly telling you very precisely. So what he's saying is like there are some conditions, there are some blockage conditions like, okay, these are the blockage conditions. If one of them is also one, basically there are many inputs which are given to them, and if multiple inputs, if one of them is also one, then basically it will be block whole new model basically, and it will not work.
There can be multiple inhibition conditions.
Yes,
Okay.
yes, there can be multiple conditions. Okay, if this is true, then block it. If this is true, then block it. If any of the condition is true, then block it.
Okay. Got it.
Question number 2. The perceptron update rule can be written as.
Ma'am, can you scroll up a bit? I mean, scroll down. Sorry, scroll down. Yes, yeah. This is okay. Yeah.
Yes, come on. Only one has answered. Come on, come on. There can be confusion between two options.
Ma'am, maybe it should be as cannot.
Huh?
No, I got it. I got the answer.
Got the answer, na? Yes. Okay. What about others? Only two have answered. Come on, be fast because I have to cover the other. Now I have written also for you guys, and it shouldn't be again we are lagging behind. Everyone, yes, come on. Exactly. You are correct. Why not C? You all are correct. Second answer is A. Why not C now? There's a confusion. Everyone can be like either it's beta transpose X or W trans. Why not C? What if it's C?
It's not a function of the input and the weights.
Yes.
It
Exactly.
could be sigmoid, it could be sine.
It's yes, exactly. It's like sine and all. Yes, Bimlesh, you are also correct. So what is this? Which update rule is this? Of which model? Exactly, Bimlesh, you are correct. It's of Adaline. Can I say? Here we were taking the signs. Here we are taking exactly that. You're absolutely correct, Bimlesh. Okay. I was thinking, meanwhile, as he told me that you can give one example, okay, of inhibitory and exhibitory. Like we can say that, okay. An example like there is a light, and if it's on pressed plus no lock is there, then the light is on. If on pressed plus something like condition here, like it's locked, something like that, it's locked, then it's like basically lights are off. And on pressed plus some other condition can be there, like here if we can say that dad locks it's off, if mom lock it's off, and if both locks it's off. So any of the conditions, if it is this one is true, then basically it's off only. Something like that we can think. Okay. Let's come to the other question number 3. I hope so. This type of confusing MCQs can come in the exam, and I hope so you'll answer it correctly.
I just have one question last one from this. F of x for a perceptron, when you say sine, it's SINE sine, right? And
SIGN. You are thinking
okay.
no, it's sign. Sign means here we were remember we were saying that okay, it's like either +1 or either -1. So we are taking here as if it's classified correctly. It's like you remember that we have multiplied also something like y into x transpose beta plus beta naught.
No,
If
I got it. Yes, ma'am. Now I got it. I kept thinking sine and
that's what I was thinking. Why you were saying
sigmoid. Why was I
sigmoid,
saying sigmoid? Yes, and now I understood.
understood. The perceptron can classify a data only if its data is normalized, data is linearly separable, learning rate is small, or error surface is constant. Yes, a very simple one. Exactly. I think I know. Swarupa, please write the question as well, like third or fourth. Okay. So exactly, I don't want to. I don't need to. I think explain you. If and only if data is linearly separable, then we can classify the data set basically correctly. That is with the perceptron. Adaline differs from the perceptron because it uses binary class outputs for weight updates. It uses raw linear classification. It has low learning rate, or it cannot handle continuous out inputs. Come on. Come on, come on. I think you might get confused because maybe I haven't focused on this much. Come on. Should I wait or should I proceed? Everyone has answered. Yes, exactly. Why it's B now? You all have answered correctly, but why it's B? Raw linear activation means I'm directly taking beta transpose X. I'm not the output before threshold, I'll say. There I was taking the sign and all. Here it's like output before threshold, whatever it's like y is equal to beta transpose X I'm taking. And then I'm comparing it with the y. So that's why we are not having any threshold and all for this adaptive linear neuron Adaline. We are using the raw linear activation for this error calculation. Now, can you tell me what is the error function in Adaline? Are you able to see all the options?
No, ma'am.
Okay. Is it now visible?
Yeah, this is better.
Come on. Come on, come on. It's easy one only. So the answer is B. Srinivas, it's not A. We are basically taking MSC. So that's why it's B only. Y minus the target minus the actual output. The target minus the predicted output, I mean to say. Why can't a single layer perceptron solve XOR? XOR is not convex, XOR is not linear separable, XOR inputs are binary, XOR requires inhibitory inputs. Yes, simple, very nice question. Be fast. We have to cover the syllabus. Come on, come on. Exactly. The answer is B. XOR is not linearly separable. Which of the following makes XOR solvable? I'm not explaining. I'm perceiving that you all know about this. Which of the following makes XOR solvable? Adding hidden layers, transforming input features, both A and B, or decreasing the learning rate. Okay. Out of my surprise, how you are answering correctly, I don't know. Maybe okay. Maybe you have listened the lectures and all.
Ma'am, I'm sorry, I didn't understand how hidden layers, adding hidden layers is there. I understood B, but not A.
Because we haven't done it. How you okay? So exactly. So it's like transforming input features. You got it, na? Actually, till now we have already dealt with like how transforming input features can help making it linearly separable. We'll come up with adding hidden layers. Though I should have given you the question afterwards. Okay. Fine, Gaurav.
Yes, ma'am.
Eighth question. Maybe I haven't. Okay. Which of the following correctly represents the chronological? What do you think? Exactly. It's 8B. In a perceptron, when a weights not updated. I hope so. You should answer it correctly.
Right at the beginning.
When a weights not updated. See the options. You are saying right at the beginning, okay, before the updation, but see the options. Then answer. I told you, in perceptron.
Okay, shouldn't it be randomly updated, right?
Randomly initialized.
Randomly initialized. Yes, fine. Yes.
It is randomly initialized. Okay, always updated, Gaurav. But what we have done, when the points are correctly classified in perceptron, we'll not update the weights. When they are misclassified, then only we'll update the weights. We'll only work with the points which are misclassified.
Okay.
Got it?
Got it.
You got confused, I think, by initial weights. We are not talking about the initial weights which are not updated. We are saying that when will the weights not be updated? We'll not deal with the points when they are basically correctly classified. We'll only deal when the points are not correctly classified. Am I correct?
Understood, ma'am. Yes.
Okay, let's proceed forward. So let's see this as a neural network. So we have an input layer. Maybe it's looking like too clumsy. So we have this. This is the input layer. This is the hidden layer, and this is the output layer. So there is some input, which is neurons, which are given. Then there is some output, and there is something happening in between. That is basically hidden layer. So let's see this. This is basically a 3-layer architecture. You can see that, okay, there are 3 layers. One is this input, one is this hidden, which is hidden to us. Only input is seen and the output is seen. The hidden is what is happening in between. That is what is input. So what is the problem with GD in perceptron? When I was saying that in perceptron, what we were doing is, okay, I haven't focused to that point. We were saying that in perceptron learning, we were basically doing the sign function and all. Am I correct? How I'm saying it's non-differentiable? Anyone? So let's. I'll have the question with you only. I'll leave this question to you only. When we do the perceptron learning, so when the points are actually on the decision boundary, they are actually on this decision boundary. On this, they are basically non-differentiable. We can't differentiate it. Why? I'll leave this question to you. Just giving a hint. Whenever we'll do it, the answer will be undefined. Next lecture, I'll ask from you guys how. Okay, when it is greater than 0, then it's differentiable. When it is less than 0, it is differentiable. But when it is basically equal to 0, it's basically undefined. That's why we were using SGD and not gradient descent, taking all the points. So what we were doing is we were taking the weights which are misclassified, but we were not taking actually on the margin points. So here, what I'm saying is when they are on the margin points, that is basically this non-differentiable. So we can't use standard gradient descent. But in Adaline, we were not using this threshold. We came up with a linear output. Should I leave this question to you? What is the problem with GD in perceptron? Answer me in the next class. One thing is, please remind me so that I shouldn't forget. Is it fine?
Ma'am, just one question. The answer cannot be too much calculation, right? Or calculation heavy,
No
right?
calculation. No calculation. When
No,
you
not calculation heavy is not the
no
answer.
no. Calculation is not, it's no, the answer is not calculation heavy. It's something else. It's like I'm saying it's not differentiable. The answer is undefined. There is no gradient. Just think about it. Because of the step function. Why? Because of the step function, it's non-differentiable. And in Adaline, we are not using, like, we are basically not dealing with the threshold thing. That's why it's differentiable. Think about this whole page. How Adaline is linear and it's differentiable. Why I can use a gradient descent. Why in Perceptron I can't use the standard gradient descent. Why I am dealing with, I told you that I am dealing only with one misclassified point, updating that. You know now that in Perceptron we are only dealing with one misclassified point at a time and then updating it. We are not dealing with gradient descent. What does gradient descent tell us? Like you told me that all the taking all of them together rather than taking each of the like weight, rather than taking each misclassified point, taking all of them together, taking
Yes.
all the observations together. Why we are not doing that? Taking all of, though time is one factor, but the other factor is it's non-differentiable. Now I want the answer from you, that why it's not, how it's non-differentiable, why I'm saying this, why I'm repeating this, and
You
how
said
at
it's a step function, it's not a smooth curve, and that is where you won't be able to find the limits from both sides.
yes, exactly. So maybe I'll elaborate. Maybe I'll let others also think about the step function. What you are saying, like if this will be equal to 0, I'll let others also think about this. Then I'll come to the. I'll explain in detail. Yes, you are correct. Absolutely correct. I'll not eliminate. I'll not tell you in detail about this. Maybe leave up to you. So now, okay. Problem with linear output multi-layer perceptron. What can be the problem? Adaline, basically, it's what I'm saying. There is no threshold, so I'm getting rid of this. I'm getting a linear output. So can I take this This is multi-layer one. Now, can I take this? Again, I'll explain this rather than reading it. So what I'm saying is, I can make it linear only. Can I make that there is a linear output here? Linear output here. What I'm saying is the Adaline is linear in nature. This is non-linear in nature, perceptron. This you should answer, though he has given you a hint by answering the step function is not smooth. Something he has given the hint. I want you should think about this. Why the step function is non-linear? Non-linearity is there, and here we are not taking the threshold. Why it's linear? Simple answer he has also given, but I want to think about you to think about this. So what I'm saying is here, can I take this linear output only the way we were taking in Adaline? Can I take this and can I work it with what is Z? Okay, this is Z. What is Z? I can say alpha transpose X. What is Y? Z is basically the output of this. Output of this means weight and input. What do we do usually? Weight transpose into X when we are dealing with the matrix alpha into X, alpha transpose into X. This is Z. Now, what is Y? Which is beta transpose Z? Can I say? Or I can substitute the value, which is beta transpose alpha transpose X or alpha beta transpose X. So what I'm trying to do here is I'm just stacking the two layers. Can I say that? I'm taking a linear function, output a linear function, then another, that output is the input of the last one, and I'm coming up with the linear function. So I'm collapsing into a single linear transformation. Can I say that? Are you getting my point? What I'm saying is, what is Z? Alpha transpose X. What is Y? Beta transpose Z. It's just a 3-layer. What I'm saying is they both are linear. The output is linear. Will it have some like a relevance for me? Will it help me? This multi-layer perceptron, like MLP, having a 3 layers, will it help me? Anyone? Yes, come on. Come on, guys. First of all, tell me any doubt. You are getting the point. First of all, tell me, give me thumbs up if you have understood what I am speaking, what question I am asking. If you haven't understood, again I'll repeat. Yes, come on.
Madam, it will help if you could repeat, ma'am. Sorry.
Come on. It's fine. No need to be sorry. I'm here to help you guys only. So what I'm saying is, I have input. Okay. This is the output of this. This is the output of this. What is the output usually? We say that y is equal to beta transpose x. This we have done from the start of the lecture. Now, here can I say that z is equal to alpha transpose x? Because these are the weights and this is the input. Can I say? Fine.
Yes, yes.
Now, can I say y is equal to beta transpose z? Because this is the input, this is the weight, these are the weights.
Yes.
Can I say? Okay, fine. Now, can I substitute the z value? The z value
Alpha transpose
x.
Yeah,
Just
yeah.
right. So,
Yeah.
what I'm doing is I'm just, rather than having one layer, I'm taking two layers, nothing else. I'm just stacking two layers. So I'm not getting anything express. I'm not by multiple layers. If I'm taking linear in nature, nothing non-linear, nothing else. I am doing nothing, just I'm having a linear input, then linear output, then linear. It will not help me. Final output is simple. Just having more layers, no expressive power is at. Limitation again is the same. If I'm dealing with non-linear decision boundary like XOR, it will not help me. Can I say? By simply taking this, stacking these layers, will it help me? No, because it's like linear only. Again, I'm not able to separate it.
So are you putting two separate weights is what you're trying to say?
Just
Alpha is one separate weight, beta is one separate weight. That would help. That's what you're trying to say.
I'm saying it's not helping me. That's what I'm saying.
Okay.
What
Okay.
getting my point? I'm saying that they are not helping me. It's like by stacking two layers, it's like simple. Z is equal to alpha transpose x, y is equal to beta transpose z. Actually, they are not helping me. Just I'm stacking up the two layers only. Now, again, they are not helping me in non-linearly separable data. Can I say? So I need something which will help me when I have non-linear decision boundary. So I took I'll say a sigmoid function. What is sigmoid function? I took a non-linear activation function, which is sigmoid function. Have you heard about it?
Yes, madam.
Where?
This sigmoid, basically, it is activation function in case of binary type of output, classification type of output.
Yes, 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 exactly. Anything else? Anyone else want to speak about this? Have you heard before in any modeling technique?
I've come here learning Sigma. So if it is anywhere close to uh, positive, it'll become one, and anything less, like anything above zero point 0.5 will directly be become one, and anything below zero point 0.5 will become zero. And that's the sigmoid function.
Have you done it in any of the modeling before?
No, ma'am.
Logistic regression.
Yes, exactly. You forgot. We have used in logistic regression.
Yes, log of this.
Log of this. Yes, exactly. We came up with the sigmoid function. Softmax also I told you, like when we are doing multi-class, this is the binary one.
Y of y actual into y predicted, which is function of sigmoid. And yes, understood.
Yes, exactly.
That's the error.
So what I'm trying to do here is I'm introducing a sigmoid function. What I'm trying, again, let's try to understand it. So I was saying simply by layering up it doesn't say me like I'm simply layering up, I'm simply adding a layer. It doesn't help me. If it will help me, if it will actually basically do the problems like XOR like problems which are non-linear. So I took a sigmoid function which will help me. So how I'm doing it, taking a sigmoid function of alpha. What is it? I told you what is it? That is alpha transpose x. That is what I told you. The same thing I have written. That is alpha naught m into like this m is something like the Zm is equal to alpha naught m plus alpha naught m transpose x. The particular, have I taken m? Okay, maybe I haven't taken the particular neuron. Basically, it's like having a sigmoid function over this. Earlier, I was saying that Z is equal to alpha transpose x plus alpha naught I should write. Usually we do this, intercept term. Now I'm saying that rather than only layering up, let's add a non-linear activation function, which is sigmoid, which can help us. How it will help us, we'll try to see. Any doubt till now? We know that how the sigmoid function looks like. It's basically what we are trying to do is we said one more thing. We said perceptron learning, it's basically non-differentiable because there is a non-linear function. That you have to check that step function and all. That is a non-linear function. That's why if I come to Adaline, we get rid of that threshold and all those things, and we are getting a linear out. Now I said, okay, let's have the linear thing in this neuron network. But having a linear thing, like it's non-differentiable at 0. Okay, leave that. Okay, having a non-linear thing, having a linear thing, it's not actually helping me. It's just stacking up the layers. It's actually not helping me with the non-linear decision boundary. So I said, let's take a function which is actually differentiable and which is actually non-linear, which can help me in the functions like XOR. You got the storyline? Come on. You got the storyline?
Yes, ma'am. So no linear decision boundary. Like in the middle, the hidden layer will use.
So, okay. I'll tell you the answer of that. That is like when I take the step function, okay, that when it will be equal to 0, then it's basically undefined derivative. Maybe you can look at to it in detail. That's why we came up with the Adaline, and in Adaline it was linear. We tried to have the linear, but again it was not solving the problems like this. So I want a non-linear function which is actually differentiable as well. So we find out, okay, sigmoid is a function which is non-linear as well as differentiable. Can you tell me anything else about sigmoid function? How, like by the diagram, or what do you want to say? First thing, it ranges between 0 to 1. Second thing, it's obviously a smooth version of step function. Step function in perceptron, we saw, okay, step function is non-differentiable, I have to tell you, as he has also mentioned, when it is equal to 0. But here, actually, it's differentiable everywhere, unlike and the sigmoid function is smooth and derivative of it exists for everything. That's what. And this is how it basically looks. Now it is basically from 0 to 1, and if I want I can say in simply I can say that, okay, I'll answer now the question as well. The step function, the step itself basically in perceptron learning is non-differentiable. That is the answer. Look upon this, but here we came up with the sigmoid function which is actually differentiable as well as non-linear also.
Ma'am, just one question. Ma'am, perceptron is an x, like it's a square function, right? So it is differentiable at least once. Are you saying it should always be differentiable? Is what you're trying to say? Sigmoid is always differentiable. I know.
Sigmoid is always differentiable, but step function is not always differentiable. When it comes to 0, it's not differentiable. It's undefined.
Yes. So that is what you're trying to say when you're saying stepwise is okay.
So that is a nice thing about this sigmoid function. And when I come to when I want this from range from -1 to +1, then we have tan HV. And tan HV, like as this is the formula for the sigmoid, and this is the formula for the tan H. Fine. Should we proceed? Come on, guys. Give thumbs up if you're getting it. What about others? Only one thumbs up. Yes, Megha, Nidhi. Swastik, Swarupa, yes. Anusha. I hope so. Now the things are getting clear. So let's say that this is the input to the out. Yes, ma'am, got it, Meenakshi. Okay. Let's say this TK is the input to the output layer. What do you mean by that? Let's again see that. TK, What do you mean by this? Beta naught K plus beta K transpose Z. Again, the same thing. What I'm doing is beta transpose Z. That is basically the input given to this Y. That I'm saying that as TK, taking a variable. That is what beta transpose Z na, plus beta naught. Just I'm taking a variable that is TK, which is an input to the output layer. So what is the input to the output layer? This Y, this layer, what is the input? That is beta transpose Z plus beta naught. Let us say that is basically TK. And let it be that there is the output layer Fk of x, output of the final layer, which is Fk of x. And let us apply another function acting on T, which could be sigmoid or which couldn't be sigmoid, which need not be sigmoid. So what we are saying here is, this is basically sigmoid when going to the hidden layer. The other function which is acting on the output layer, which can be sigmoid or which cannot be sigmoid, which may not be sigmoid. Are you getting my point? Here Zm. Zm is equal to, we'll come to again this. I'll write here. This Zm is equal to alpha transpose x plus alpha naught. So here we have applied sigmoid here. Now I'm writing Tk. What is Tk? It is equal to gk some function, and which is beta transpose z plus beta naught. Now this gk, it may be sigmoid or may not be. Fine? Fine, guys? So this gk, this is the function acting on this t, input to the output layer. So as I have told you that there is a hidden layer, there is an input layer, and there is an output layer. So input layer, it's basically a fake layer, nothing else. Just taking x, giving x, nothing else. Hidden layer, we don't see this layer, and output layer, whatever the output is there. Fine. Any doubt till now? Come on. Come on, come on. Can someone give me summary what I have told you till now? Then only I'll proceed.
You have three layers, ma'am. There's an input and output. In the middle, you either you put a layer with the sigmoid or the tan H function, and in the end, you put regression if it is a linear regression problem, and if it is a classification problem, you put sigmoid.
So exactly, he's correct. Now we are coming to, as he has told earlier only. Now last layer activation function, what I'm saying is, if it's like a regression problem, I can simply take it as linear, and there'll be loss function is MSC. And if it's classification, then I can take it as sigmoid. Why it's like that? Come on. What was the loss function and a logistic regression?
Ma'am, it is y actual. It is it is the average of the sum of y actual into
What do we
the
call?
sigmoid of
What do we call it? Like we have this MSC here. What do we
the
call?
sigmoid. In logistic, it's sigmoid.
No, no. The activation is sigmoid. What is the loss function called? Sigmoid we were using as probability, like the activation function, if you remember. What there was
Yes.
a term called to loss function, like we are taking MSC, and there is a term called in logistic regression for I don't know whether I have told you or not, for loss function in logistic regression. Anyone? I don't remember if I have told you. Basically, it's called cross entropy. No, I haven't. Na? I haven't told you. I think. Maybe I have mentioned what is that cross entropy loss function. We have calculated actually, but I think I haven't told you. I don't remember actually. So maybe I have missed it out. So basically, in logistic regression, we do have this cross entropy, and when it is basically classification, we are basically not using the linear function. The last function is not linear. We are basically using the sigmoid function itself, because sigmoid function we have seen. Why sigmoid function?
If it's on or off, so if it is yes or no, it's 0, 1. If it is anywhere above or below 0.5, we'll get the classification as 0 or 1. So it's okay if it's if it's somewhere around 0.5, as long as it's in the correct side.
Can I say the output should be bounded in 0 and 1? In linear one, there is what we did is, if you remember, we have done that output when we were doing, like, why we switched from linear classification to logistic regression. We said that there is the output is unbounded. There is no meaning of the probability. We want that the probability should lie between 0 and 1. It should be interpretable as probability. That's why we came up with maximum likelihood estimation for classification, and that's why we came up with the sigmoid function. Please do revise the lecture of logistic regression once again. You'll get this. Okay. Why I have told you, like, why we are doing logistic regression, because 0 and 1s, because the probability should lie between 0 and 1. When we're doing the linear classification, it was unbounded. There was no meaning of the probability. So that's why we came up with this, and that's why we need the function as sigmoid function in our last layer. Basically, when we are doing classification and regression, the last layer, basically this function, it can be linear as well. Fine. Talking about multiple output regression. What do you mean by multiple output regression? Can I say what is regression? Dependent variable, independent variable, output is independent. Can I say I have multiple independent outputs I'll have? So we can have multiple output regression as well. We haven't talked it before as well. And what about classification? Can we have independent terms there, output? Can we have in classification independent output? Come on. I'm saying that in regression, the output is independent. That's what we have learned it so far. We have dependent inputs, independent outputs, and we can have multiple also. Can we have in classification independent outputs? Come on, come on. Come on, guys. Why, Nusha? Why no? From which it is dependent and independent. Yashwant, I'm asking, like, in classification, can we have independent outputs? Classification problem, we do have probabilities. Am I correct? Like, what is the probability of a data point lying in which class? But obviously, we can't have independent, because if class 1 probability is high, we need that the class 2 should be low, lying in that point. Like, one will depend on the other point, because some of the probability should be 1 Can I say? So classification, we can't have independent outputs. Again, we can use softmax also. Have you heard about softmax? In linear regression, if you remember that, we do have heard about, in logistic regression, we do have heard about classification. When softmax, when we were doing multi-class classification, when we were doing linear classification by two class classification, multi-class, then we were using sigmoid function, and when we were doing more than two class, then we were doing softmax. So for two classes, it's sigmoid, and for multiple classes, it's basically softmax is used. I'll not go in detail. Any doubt till now? Come on. Nothing extra I have told you, just whatever we have covered earlier. Any doubt? Okay. So, coming to neural network parameters. So we are seeing that, okay, alpha naught, alpha m, beta naught, beta k. These are the weights associated with the first layer. These are the parameters associated with the first layer. And this m, let's denote it. This m basically, alpha m, basically it lies to alpha p, obviously, because the inputs are this, and beta 1, it lies to beta m, because the inputs are basically zm. So that's what we are denoting here actually. Fine. Fine, guys. Am I doing something wrong? Alpha m. Oh, sorry. Alpha m because the output is m. Alpha 1 to alpha m, sorry. And beta 1 to beta k because the output is k. Because I have to connect it to k outputs. Fine. Have you heard about multiple layers? Like this is ANN. I am having 3-layer architecture. Can we stop at 2 layers? Why usually we think that you have seen the neural networks, multi-layer one, that we have many layers, deep neural network, I'll say. Why do we we should stop at 2 layers? We should extend more than 2 layers. If do this 2 layers, they are solving our problem, or they are not solving our problems. Why we are moving to DNN nowadays? Any idea?
In the lecture, it was told that after 2 or 3 layers, it becomes, it stops giving correct answers, I think.
What about others? I can't
Maybe it
got it.
requires additional computation power
Mhm.
for to and fro calculating weights, optimizing. So
Then
if we keep on increasing layers, then
Mhm.
computational power required may be very
Huh.
high.
You are correct that computation it will be expensive. Do this more layers help us? He's saying no. Gaurav is saying no. What about others for accuracy? Yes, Anusha. You are correct that it's computationally expensive. Okay. Why we are doing DNN nowadays then, Gaurav? If you are saying that more than 2 layers, it's not giving us good answers or so, then why we are doing many layers, deep neural networks? Why we are dealing with that?
That's why I said it was in the lectures. It was said that way. That's. I'm not sure.
Okay. Actually, more I'll say that we can implement these 2 layers. It will actually help. It is actually less computationally expensive, as he said. And if I have very complex problem, I'll need more neurons actually. More neurons will be there. And if I'll have uh, more layers, I'll have less neurons. That is actually opposite what I was saying. Are you getting my point? I can have more layers and less neurons. Then how it's computationally? I told what he said. Now what I'm saying is neurons can be reduced actually by reducing by making it by having it more layers. Does it make sense? And we can reuse the features. It will be more efficient actually. when I come to practical implementation, if I'll add more layers, actually, I can have lower number of neurons. And it will be, the features can be also reused, which were used before. Though I'll not go in depth of that, just a glimpse of it I want to give you. Any doubt? Any doubt? Now, can you say, is it computationally expensive? Obviously, in one way, we can say that sometimes it's like there. Each new layer will introduce new weights, new bias, more parameters, more memory, more computation. But on other hands, we can reduce the neurons as well. And the other weight is obviously it's more power will be increased. Like suppose I want to have a image recognition. First layer will like learn the edges. The next layer will learn some shapes. The next layer will learn the whole object. Something like this, and we'll go in more possible depth actually. Adding more layers is expensive because of more parameters and all, but it allows hierarchical feature learning, I can say. Making it deep is much more powerful than shallow ones, I can say, but I should have a trade-off. How many to increase? That is the main point. We'll come to that also. So one thing in regression, we are using simple MSC, loss function, as I have discussed. You know about this, need not to be explained. And in classification, we are using this cross entropy loss function, yik log fk of xi. You can refer again to logistic regression video. I'll not repeat it. And then we are finding it, what is the argmax of k, which feature, which is basically giving me the less loss. This is again the repeated version only. Any doubts till now what I have covered? Then I'll like again come to the MCQ part. Come on, guys. Come on. Was I fast at the end? Yes, Sachinji, yes. Gaurav?
Not fast, not
No
fast.
fast, ma'am. Yeah, yeah. It is very good. Yeah, it's a good pace.
Actually, you were only telling me, I think that I should have more intuitive one. Is it fine today's lecture?
Yes, ma'am.
Yes.
Yes,
Okay,
ma'am.
let's go to MCQ. Numbering is, I think that was 9th. I have actually removed some MCQs which were not beneficial. Why does stacking multiple linear layers not increase model expressiveness without nonlinear activation? Write the answers like 13A, 13B, 13C, 13D. Understood now? Whatever I have told you, just giving brief in overview of this. Have done nothing, just a sigmoid function, multiple layers, how we are basically writing them, and what is multiple layer stacking, what is sigmoid function, what is tanh, and what is 3-layer architecture, what is multiple layer, like DNN. Okay, I have written the answer, I haven't seen. Exactly, you are correct. So everyone, please write only 3 answers here. 16 students are present. Come on. Why does stacking multiple layers not increase a model expressiveness? Because weights cancel out, because multiple layers maps collapse into one layer map, because bias term dominate, because training is unstable. Exactly correct. Because multiple layer maps to one layer. So obviously it's not beneficial. I'll say nothing, no benefit we are getting by stacking. It's like one linear map we are only getting. What role does the sigmoid activation plays in MLP? Keeps output always positive, introduces non-linearity and differentiability, prevents overfitting, normalizes features. Come on, fast. Very simple answer. Come on, come on. Anusha, please write the question number. Exactly. That's why we are coming with the sigmoid activation function non-linear as well as it's differentiable on the other hand, compared to sigmoid, which is why standard sometimes preferred. It does always outputs. It always outputs positive when it saturates less than sigmoid. It's zero centered, ranging -1 to +1. It's not differentiable. Come on, everyone, be fast. Exactly, you all are correct because it ranges from -1 to +1. In regression, using MLP, the final layer is typically sigmoid activation, softmax. Now I'm talking about regression in multilayer perceptron, linear activation and step function. I told you when it's classification, then final layer is what, and then when it is regression, what, then final layer is what. Exactly, it's linear activation. Absolutely correct. Preeta, it's linear activation because this is now regression and final layer, not the hidden layer one. For the final layer, we are using the linear activation, Preeta.
Madam, is there a thing called step activation? I mean, is that option really, is that type of activation really valid, or it's just for the sake of this MCQ?
Sake of this MCQ, sake of this
Okay.
MCQ.
There is no such thing called
There
as
is a
step
step.
activation.
Usually we like the step function. Sometimes we can say that. Step function we usually say.
Yes. So no activation.
Okay.
Step
Sometimes
function, I know. I mean, I know the step function, but now these are sigmoids.
actually,
These are activation functions. So,
actually,
is there a
that
thing
step
called like?
function is called step activation function. That is what for the perceptron we were using the step function. Sometimes not usually. I'll say for the MCQ purpose only, but it can be called step activation function. But usually we call it a step function only.
Okay.
In multi-class class, are you able to see all the answers? All the options? Okay. In multi-class classification using MLP, the final layer is typically sigmoid applied. Now, for the classification, final layer is sigmoid applied independently on each class, softmax, overall class scores, linear activation without normalization, step activation per class. 17th. Come on, 17th. I'll come to 18th afterwards, 17th. Okay. Why it's soft? You all are correct, but why it's softmax at overall class scores? Why not sigmoid? Anyone?
Sigmoid has two classes, 0 and 1. I don't know what softmax is. You had mentioned that's why I wrote, but what does softmax give? I don't know. Just
I'll again say you revise that logistic regression lecture. In that, sigmoid is basically for two class, softmax is basically for the multi-class. Though professor haven't told about softmax in his class.
no, I'm asking genuinely what would be a like for example, tan H is -1 to 1, softmax is 0 to 1. What does softmax give?
Softmax is also 0 to 1 only, like sigmoid only. It's like sigmoid we deal it with two classes, and softmax I have written the I think formula also for the multi-class classification. You can see in the logistic regression video. We have written like what is softmax. Like the same way, softmax is also defined for more than two classes. Fine. 18th, why are classification outputs and MLP not independent? Because hidden layer features are shared, because softmax couples output to one, because regression outputs are correlated, because weights are regularized. 18th. I'm saying that why are classification outputs in multi-layer perceptron not independent? I told you they are not independent. No one is answering.
Maybe explain it once more if you can.
Okay. Bimlesh, you have answered. Can you tell me why B?
Yeah, because softmax, all the probabilities should sum up to 1, and because of that, it removes the independence nature.
Yes, exactly. So basically, in classification, we are saying that like this point has the probability of lying in this class. This point has the probability of lying in this class, and actually, that probability should be sum to 1. That's what like eliminates the independent feature. Like what I told you in regression, we can have multiple output regression problem. We can have multiple independent outputs in regression, but in classification we can't have multiple independent outputs. They are not independent because they are probabilities. If they are probabilities, they can't be independent. If one is high, the other will be low because they have to be sum up to 1. Are you getting my point? Yes, everyone, come on. If you have got the point, please give thumbs up. If you haven't, please ask me.
Um, would you just write it down, ma'am? That's I don't know why. I don't because I'm not getting it,
Okay.
or maybe only I'm not getting it. So
No,
sorry.
no, it's fine. Fine. It's fine. What should be the sum of the probabilities?
One till that it's
1.
clear. Yes.
1. What is the output of the class? Like what I'm saying is that I have the probabilities as the output. Okay. If the probability of lying of this data point x1 probability is, this should be equal to 1. If one is high, the other should be low.
Yes, ma'am.
Basically, they are dependent on each other because they have to be equal to 1.
Okay.
So
So that's what you're saying.
that's what that's what I'm saying. That the probability should be sum up to 1. So that's why uh, like because of that sum up to 1, increasing one probability is decreasing the other probability automatically.
Okay, ma'am. Now I understood.
Mhm. Okay, one more thing. Okay, I'll tell you. Maybe I'll take the softmax for your confusion should be reduced. Suppose I'm taking 3-class classification. Now what I'm saying is this is the formula, like e power whatever the 2. So if this is 0.71, which means that the probability of 2 class 2 is basically probability of class 2 given x is basically 0.7. 1 line y is equal to this. Obviously, y1 is this, y2 will be 0.26, and y3 will be very less because they should be basically sum up to 1. Softmax is basically like these are the probabilities which is given to me. If one probability is rising up, the other will be automatically shrinked up to give so that the answer should be sum up to 1. So that's why I'm saying they are basically dependent, very dependent. They are not independent. The sum of them, the sum of the softmax giving the probabilities, it should be equal to 1. The next question, the cross entropy. Is it clear, Gaurav?
Yes, ma'am. Yes, ma'am.
The cross entropy loss in MLP classification is equivalent to negative log likelihood of which earlier model? Come on. Easy. Exactly. Logistic or softmax regression. Actually, logistic regression. Why do we add more layers in deep neural network? Come on, fast. Come on, fast. Exactly, to represent function more efficiently with fewer neurons and learn hierarchical features. Okay. The perceptron update rule. I think I have already told you. Okay, again. This was the MCQ before also, so I'll not come across. This is 21. If perceptron classifies input using fx is equal to sign, which region corresponds to +1? Exactly. I'll not go in detail. Should we proceed now?
Yes, ma'am.
So again, this was the part which we have already covered. Now again, coming to the same continuation of that only. As I have told you that, okay, ZMI, I is the ith input, any input basically. And I have the sigmoid function on this, basically, this alpha naught m plus alpha m transpose xi. And then I have the gk, that is another function which can be linear, which can be non-linear as well. Then I came up with this regression loss, and then let's try to differentiate it. Okay. Let's now try to have the regression, the loss for the regression only. Let's not try to have the classification one, so that let's deal with the regression first. Okay, if I'll differentiate it, I'll be I'm in somewhat hurry. Let's try to get an overview. So if I'll differentiate it, that is basically -2 into gk dash vk transpose zi. How is this? Can someone tell me?
And why -2? Should it be 2?
This is minus, na?
Okay, yes, minus, got it.
This minus is coming, chain rule, na? This
Yes,
this is only,
and
minus I have basically differentiating with this.
and you're
Okay.
differentiating with respect to
With respect
Beta
to
k.
beta k. Then yes, ma'am. So then beta k will go away and will become beta naught, and beta k zi should be gone, right, ma'am? I don't know why it's there on the side.
No, no, jk dash. This is a derivative of the function gk.
gk dash. I'll come. So what I have done, this was there. Then the 2 is there. Then fk of xi, that I have told you, the output is basically gk into whatever the input
This
is.
m is to represent a particular neuron.
Yes, m is basically to represent the particular neuron. You are correct. M is, maybe I have here mentioned. This is basically a particular one. This M is basically this, any particular neuron. Any one. Okay. Any neuron I'm referring to. Okay. Any neuron I'm referring to, and basically any single weight I'm referring to, I'll say any single weight, this is M. So any single weight I'm referring to, from that beta km means, one more time I'll come to that. Okay. This is suppose K and this is suppose beta, and this any weight I'm referring to, I'm differentiating it with that. So what I'm doing is I'm taking a regression case, I'm taking a loss function of that, and then I'm basically differentiating with respect to beta, any single weight, basically. How I'm differentiating this fk is gk beta k transpose zi. Now I'm differentiating it with this. So this is basically gk, obviously a chain rule 2 into this. Then gk dash, this is basically differentiation of this. And then what will be left? If I'll differentiate with respect to beta km, that will be ZMI. Getting it? Any doubt? Yes, yes, Megha, Sachin, Gaurav, Vimlesh.
Yeah, it's clear.
No, ma'am. No,
What about others?
It could help if you can separately share with us this differentiation rules involving vectors and matrices.
Sure. I'm just differentiating with respect to single rule, single weight. What I'm doing is, okay, I'll just share it. It's like simple chain rule. What we usually do, obviously, if it's like x square, we do it 2x, 2 minus 1. That's what I have done. 2 into this minus 1. Now I have to differentiate what is inside this
No,
yi.
like
Okay,
here it is beta transpose zi. So differentiation of beta or beta transpose with respect to beta is both gives the coefficient as the ZI.
Yes.
Those things I was saying.
Okay. That matrix part you are saying, no? I'll share
Yes.
that. I'll share that. Now let's again differentiate with respect to the other alpha LM, alpha ML. Alpha ML was the weight from the hidden layer, from the input layer to the hidden layer. Can I say that? That is what alpha ML means? Beta was from hidden layer to the output one. Alpha is from the input to the hidden one. Am I correct?
Yes, ma'am.
Uh,
Yes, ma'am. So beta is the middle one, and alpha is the input. Yes.
Just I'll give you overview. So that's what I am doing now. I'll again differentiate. Maybe actually I have to go. I am in hurry. My baby is actually crying. So maybe we can.
Can we continue later?
Yes. Okay. We'll continue.
Because this is the entire back propagation.
Back propagation. So we'll need some time. I think I can't be in hurry. Though
Okay,
I thought
ma'am.
that I'll basically cover this by writing. Still, we are. I thought that today I'll, in any cost, I'll complete it. But it's fine.
Ma'am, we'll take it.
Yeah, we will continue in the next session, ma'am.
Okay.
Thank you, ma'am. We'll stop
Thank
the
We will
recording.
also be taking a numerical example to complete all the gradients and everything.
Okay, I'll take that also. I'll come up with that. Though I haven't come up in the back propagation, I'll come up. I'll add that also. Is it fine?
Okay, thank you.
We can end it right now, ma'am. We'll end it right now only. Bye, ma'am.
It's fine.
Yes.
Okay, thank you so much, class. I
Thank
hope so today's lecture was fine. Any feedback?
No, ma'am, this is good. We are slow, but because we are trying to understand.
But actually, the point is we are in 9th week, and now I'm teaching the 5th week lectures. We'll not able to cover the whole syllabus. That is the main worry which I am facing. That's why I thought today I'll write it. Like I wrote this 100-page PDF so that the time of writing shouldn't be wasted. But
Ma'am, you go back to your baby.
it's
We'll
fine.
think about how to solve it next.
Yes.
Bye, ma'am.
Thank
Yeah.
you so much.
Thank you.
Thank you,
Thank you.
class. Thank you so much.